let's graph the demand curve. What is it? A minus BP. So the demand curve looks like this, has a vertical intercept of A, and has a slope of minus B. Now, A represents the quantity that consumers would want to purchase if the price were 0. So if the price were 0, surely consumers would want to purchase some of this good. Okay, otherwise, the good wouldn't exist and we wouldn't be able to observe it. Okay, so that's, Ben, that's quite reasonable. Now, the slope of this demand curve, yeah, it's minus B. So the fact that B is positive means that it's a downward sloping demand curve, which means that the higher the price, the less consumers want to buy. Now, that takes care of the demand curve. Okay, so it's quite reasonable to assume that A is positive and that B is positive. In terms of the supply curve, this is a little more problematic, but what we're assuming is if the price, here's the price. The price were 0, the quantity that producers would want to produce actually would be negative. Of course, they can't produce a negative amount, but that's what we're assuming in terms of the supply curve. Perhaps a better way to explain this would be this. If we just graph this supply curve, notice D is positive. So if D is positive, this thing has a positive slope. The slope of the supply curve is D. And that's the law of supply. The higher the price, the more producers are willing to produce. Now, but let's go back to this assumption that C is positive. What that really means, if you draw this supply curve, it's going to intersect the horizontal axis at some price. Let's call it P1. Notice at this price, P1, the quantity supplied is just 0. So this is the lowest price you could possibly have, P1. Well, then even at P1, the quantity supplied would be 0. What you need to get positive production is a price above P1. But it makes sense for this P1 price to be positive. You have to have a price above P1 to elicit positive supply. So in order to get that in a linear model, what you need is this intercept down here actually to be negative, which means C is assumed to be positive. But that's a good question. Good question. So this is critical. These assumptions are then critical in the analysis because that's what allows us to assign these partial derivatives. Okay. So we have concluded that a parameter A and P star move in the same direction, which makes sense because as this parameter A gets bigger, this demand curve shifts up. If the demand curve shifts up because A increases, say from A to A prime, what's going to happen to the equilibrium price? Well, with an increase in demand, what's going to happen is the equilibrium price is going to go up. It's going to go from this level to this level because the demand is shifting up. If A goes down, then the demand curve shifts down and the equilibrium price falls. So that's what this means, that parameter A and P star move in the same direction. Okay. Let's move on to the next one. The next one we're looking at is this one. This is a little more complicated. Partial P star, partial B. And again, let's go back to this expression right here. In order to get partial P star, partial B, what rule are we going to use? What rule of differentiation? Because, see, we've got the ratio of two, we've got these variables, A, B, C, and D. We're treating these as variables now. So you got 2 up here, 2 down here. So the easiest rule to use would just be the quotient rule. Okay, so our numerator is A plus C. That's our numerator. What is the derivative of the numerator with respect to B? Zero, because there's no B up there. So the derivative of the numerator with respect to B is 0. A and C are just treated as constants. So that's 0. You multiply that times the denominator, B plus D, minus the derivative of the denominator with respect to B. What's the derivative of the denominator with respect to B? Anybody? 1. Okay, because there's just a B sitting there all by itself. So the derivative of the denominator with respect to B is just 1. Times the numerator, A plus C, all over the denominator squared. And this simplifies to minus, you've got a 0 there, A plus C over a B plus D squared. So what is the sign of this expression right here? What is the sign of that expression? William? Negative, right, because you got a negative sign out there. You've got A plus C. A and C are both assumed to be positive. You got B plus D here squared, so this has got to be positive. So that's positive, but then you multiply this positive thing here by a negative sign, so this is negative. So, William, what does that mean? The fact that partial P star partial B is negative. What does that mean to us? Okay, well, all right. Well, let's learn. When the derivative is negative, that means the thing in the numerator, this P star that you're differentiating, this is the partial derivative of P star with respect to B. So the fact that this derivative is negative means when B gets bigger, P star gets smaller. Or also when B gets smaller, P star gets bigger. They move in the opposite direction. Whenever a derivative is negative, the two variables here are moving the opposite direction. So as B gets bigger, P star gets smaller. Now this actually makes sense in terms of supply and demand model, because here's our original curve. Here's our original supply and demand curves. Here's demand. Here's supply. And our original price is right here. Call it P star 1. Now that's for our original values of A, B, C, and D. But now, what's happened? Let's assume that B gets bigger. So in your diagram, if B goes up, what changes in this diagram? If B goes up. Exactly. Because the slope of the demand curve is just minus B. So as B gets bigger, that demand curve is becoming steeper. It has a negative slope. So here is our original B value for this demand curve. And let's call our new value of B, B prime. So the new demand curve will look like this. and it has a slope of minus B prime. So the demand curve is becoming steeper. As the demand curve becomes steeper, your equilibrium price, this was your original equilibrium, capital A. Here's your new equilibrium for the new demand curve. What happens to the equilibrium price? It goes down. Okay. The equilibrium price falls as the demand curve becomes steeper. Okay. If B had gone down, then what would have happened? The demand curve would have become flatter. And if it had become flatter, the value of B actually goes down, then your equilibrium price would have risen. So this is consistent with the idea that B and P star move in the opposite direction.